Costa Rica is located in a very interesting part of the circum-Pacific subduction system. It's really interesting because it has the interference of several ingredients. For example, we have subduction of oceanic lithosphere formed at two different spreading centers. One is the East Pacific rise, that is trending more or less southeast northwest, and the characteristics of East Pacific rise is to produce this very, very smooth oceanic lithosphere. Instead, striking east-west, more or less, there is the Cocos Nazca spreading center. And this one, mostly because it interacts with the Galapagos hotspot, which is basically, you can visualize it as a non-stop volcano, always producing material, and it has produced material for a very long period of time. So, due to this interaction, mostly, we have a production of oceanic lithosphere and oceanic crust that is very, very complicated. With the Cocos Ridge is the main feature that we can see, is this seismic ridge that is about 2 kilometers high on the average seafloor, and not only has 2 kilometers high, but is also very deeply rooted. So if the normal, say, East Pacific rise has a thickness of about 8 kilometers, the Cocos Ridge has a thickness of about 20 kilometers. And the Cocos Nazca spreading center has not been stationary, but has jumped at least 3 times. There is another important feature here, that is the boundary between the Cocos Plate and the Nazca Plate, which is a fracture zone, a transform fault, probably, and that's the Panama fracture zone, which is a north-south fracture. And this is right now located beneath the southwest part of Costa Rica. So what you have here is really a triple junction that is migrating along the trench. You have a triple junction trench transform fault that is interfering with the Cocos. There are lots of seamounts that have been created by the Galapagos hotspot, and these very different pieces of oceanic lithosphere formed at different spreading centers. So it's a very complicated part of the world. But it's also very fascinating because, if you wish, it's a very unique place where we can study lots of different processes. For example, it has a very active volcanic arc, so we can study the whole system, subduction, volcanic arc. It's very active seismogenically, so we can study the processes that are related to earthquakes. It's a very unique place in the world, where we have lots of processes, very concentrated, and if you wish, they are so exasperated that they are easy to study, because everything is occurring so rapidly that it's another factor that can help us understanding what's going on. So it's a very unique place, this one.